Okay, in this video we are going to look at what it means to have an exponential function and then what it means to graph that exponential function. So first and foremost, we need to know what is an exponential function. So a function is considered exponential if your base term is some value, either a number or a variable, raised to a variable power. Now in most cases, your base here is going to be an actual number, and then we're raising that to a power. And the thing that you have to keep in mind is that your power is going to be a real number. Okay? So, in order to graph this, what we actually need to just do is go ahead and make yourself an XY table and then graph those scatter points. So the easiest thing to do is going to be to use the values from -2 to 2. And that's going to give you a really good snapshot kind of centered right here around the origin so that you can see what's going on with your graph itself. So we're going to create that table, x, and then we have that y is going to be 4 to the x. And again, we're going to look at those values that go from -2 to 2. So we're going to start with -2. And then we're going to plug it in. So this becomes 4 to the -2. Well, we know using your exponent rules that my negative means I need to flip it. So this really becomes 1 over 4 squared, which is the same as 1 over 16. So here we have -1, so again 4 to the negative first says we need to flip it, and anything raised to the first power is itself, so we get 1 over 4. Then we've got 0, so 4 to the 0 is going to follow the 0 power rule, which says it doesn't matter what it is, you get 1 as a result. Then I'm going to look at 1. So here I've got 4 to the first, which is 4. And then I'm going to look at 2. So here I've got 4 to the second power, which is 16. So we need to plot these points here. So I'm going to plot my points, and I'm going to start down on these sides. So I'm going to start with these. And the reason I'm going to start with these points is because they're the whole numbers, so they're the easier ones to plot. So here I've got the point 0, 1, so I'm going to go ahead and put that down. And then I've got 1, 4, so over 1, up 4, 1, 2, 3, 4. And then 16 is going to fall off of my graph, so I'm not going to be able to graph it because it's going to be like way up here. And now I'm going to look, I have at -1, I'm at 1/4, so that's going to be kind of close to the axis. And then at -2, I'm at 1/16, which is even closer. So you can see here that this graph is actually approaching my x-axis, and then it's going to curve up, and then it curves up very quickly. So this is the graph that I actually have. Okay. So there's a few things that we need to notice about this graph. First, we are curving towards the x-axis. So if we look at it, this is actually considered to be an increasing graph. So increasing, you would start on your smallest side. And if we look here, we are only ever increasing. So here, this graph is increasing. Which means it has a domain that goes from negative infinity to positive infinity, and it has a range that is going to go from 0 to positive infinity, because what this graph is never actually going to do is cross that x-axis. So my range here goes from 0 up through positive infinity. And that's what exponential does. It crosses your y-axis, but it never actually crosses the x-axis. Okay. So let's look at another example. And this example has a little bit more to it. So here we want to do the same thing. We want to make our graph, and we want to use 2 minus 15 over 4 raised to the x power. So I'm going to do my same xy graph. And we're going to look at what that does. And for this one, I would definitely make sure that you utilize your calculator to make your life easy. So we're going to start at negative 2. So here this is going to be 2 minus 15 over 4 raised to the negative 2 power. And so I'm going to use my calculator to help me out here, just to make life a little easy here. So I'm just going to start putting in exactly what I see. So I have 2 minus, I'm going to open a parenthesis, 15 divided by 4, close that parenthesis, and then I need to do my power, so I'm going to hit my power button, and it is negative 2. So I'm going to hit enter, and it's going to give me this really large fraction, which is fine. So I have the fraction 434 over 225. Now I want to know kind of what that is as a decimal. So on my particular calculator, I have this button down here that goes from fraction to decimal and vice versa. And so I'm just going to go ahead and click that button, which it then takes the fraction that was my answer and gives me the decimal. Now some of the other calculators that are out there, if you were to put this equation in and hit enter, it would automatically give you the decimal. But the whole point is that we need to know kind of roughly where we're sitting. So this would be 1.93. Right here, this should tell you that we are getting really close to just simply approaching the 2 line. So we're going to keep going to look at what the rest of the graph looks like. And so here, 2 minus, and then I've got 15 over 4 raised to the negative first. So again, I would do the same thing. 2 minus, open that parenthesis. Then I have 15 divided by 4, close it, raise my power to the negative 1, and hit enter. Notice I get a fraction again as 26 over 15. Again, convert that to your decimal so you can see where you're going. So 1.73. You're going to keep repeating this pattern throughout the whole rest of the problem. So here we have 0. So 2 minus 15 over 4 to the 0 is going to give you 2. Minus 1, which equals 1. Why is because anything raised to the 0 power is 1, and then we still have to input it into your problem here. Now we have 1, so we've got 2 minus my 15 over 4 raised to the first power is going to give you negative 7 over 4, which is negative 1.75 as a decimal. And last, I have 2 minus my 15 over 4 squared. is negative 193 over 16, which is the same as negative 12.0625. So we have to graph these points. So I'm going to start again with my middle point. So I have the point 0, 1, which goes here. And then these are all decimals, so the order in which you graph them is completely up to you. I like to graph positive first and then graph my negative, but it's your choice. So here I would graph the point 1, so over 1, but I'm going to go down 1.75. So down 1 and then almost to 2. And then the second point here is going to be off my page, so I'm not going to worry about it. At negative 1, I go over 1 and I go up 1.73, so kind of close to positive 2. And then at negative 2, I'm up at 1.93. So what you're going to notice here is that this graph is actually curving towards the 2. So it's going this way, and then it curves around and shoots down really fast. Okay. And so that is the graph that we have for there. In this graph, if you look at it, we are actually decreasing. Okay. If we look at it, we would say that this graph is curving towards y equals 2. We also know that my domain is going to be all real numbers, which is negative infinity to positive infinity. And we know the range is going to go from negative infinity up to 2. Okay. So in general, we have a couple comments. So first and foremost, if your base is greater than 1, then your function is forever increasing. If your base is a fraction that falls between 0 and 1, then it is forever decreasing. For the most part, you are going to have a domain that is all real numbers, but your range is going to go from whatever number you approached to, either up to positive infinity or down to negative infinity. And in most cases, your y-intercept is going to be the point 0, 1. Okay, so those are some facts that we have about graphing your exponents. Now, another exponent form that we have is called base E. So base E actually has a value. It is an infinite value, and it has a button on your calculator. Okay, so if you look on my calculator here, I've got this E to the box. So that is my E button. Well, on some calculators, it looks like mine, where you have E and it gives you a little box. On other calculators, you might be looking for E to the X, or just simply E. Okay. Now you need to pay close attention. So if you notice, on my calculator, my E is on an actual button that I push, but on some calculators, it would be in the writing above it. So if that's the case, then you would have to push the second button and then whatever button is below in order to access your E. So you need to pay attention to where it's located and to know what you have to do on your calculator in order to get it. Now to evaluate is purely a calculator problem. So I want to know e to the fourth. So for me, I'm going to hit the button, so on my calculator, I'm going to hit my button that says e to the box. And then once I do that, I'm going to input my 4 and hit enter. Okay. If you have to do second, then on your calculator, you would have to hit the second button first and then use your E. But for mine, I don't have to do that. So I'm going to go ahead and hit my E button. I'm going to input my 4 and then hit enter, and it gives me a decimal. And I'm going to go ahead and round out 3 places just to be in the habit of doing so. Remember, you need to round however you are asked in your specific problem. But here we end up getting an answer of 54.598. Now I'm going to do it again for my problem over here. So again, on my calculator, I'm going to hit my E button. Then I'm going to put in my negative 2.458 and hit enter. Okay, so let's look at that. So we have E, negative 2.458, and hit enter. And we get 0.0856. Okay. Now we can graph this as well. Again, we would make an XY table. So x, y equals e to the x. Again, I would start with negative 2. So this is going to be e to the negative 2. Use your calculator. So we're going to have e to the negative 2, hit enter. And in this case, we're going to go ahead and round to the tenths just to make it easier. So here we're going to say 0.1. And we're going to repeat the process for the whole table. So at negative 1, we have e to the negative 1, which is going to be 0.4. They're then going to have e to the 0, which is 1. At 1, we're going to have e to the first, which is 2.7. And then e to the second is going to be 7.4. So as you can see, I've already graphed this for you to try and make it easier. So here are the coordinate points that we graphed, and you notice my graph is going to cut through them. So again, some facts about it that we know. This one is an increasing graph. It has a domain that is all real numbers, and it has a range that's going to go from 0 to positive infinity. Okay. Now, another thing that we can do with our exponents is we can do what's called transformations. Transformations are where you are going to take that base function and you are going to move it all over the place. So when we dealt with, or when you deal with transformations for normal functions, we have these 6 rules, where we have vertical and horizontal shifting, we have vertical and horizontal reflections, and then we have vertical and horizontal stretch or compress. And so with this, we can apply that to your exponentials. So if you notice, my vertical shift here is still being a constant added on to the back end. My horizontal shift, though, is an internal shift, which means it now gets done inside the exponent. Okay. My vertical reflection is still an external reflection, so it's done outside, but horizontal is internal. Internal means directly onto the variable. So here, this is done inside. For my shrink or stretch, the same holds true. We are multiplying by a constant, so vertical is external, which means the multiplication is done on the outside. If that constant is greater than 1, you have a vertical stretch. However, a horizontal is done up in the exponent. Okay, it is internal, so it's done in the exponent. And in this case, if you have a constant greater than 1, you have a horizontal shrink. Okay? So we have to apply this idea when trying to graph. So let's look at this. We have f of x is 4 minus 3 to the negative x. So what do we know? Well, we know that this negative sign right here is going to be vertical. Furthermore, we also know that it is a reflection. Up in the top, we also have a negative. So this one is horizontal. And it is also a reflection. Okay? Well, beyond that, we need to be able to identify the rest of what's going on. So I would rewrite my formula so that I have my shift placed where it's supposed to be. So this is going to be f of x is negative 3 to the negative x plus 4. So this right here is going to be a vertical shift. So what do we know? Well, a horizontal reflection means you're going top to bottom. So this is going to be a reflection where we are going over the y-axis. Sorry, horizontal is left to right. Vertical is top to bottom, so we are going over the x-axis. Okay. So the first thing that I would do is I would identify what your base function is. Well, my base function is going to be that f of x is 3 to the x. So I would go ahead and graph that so that I can see what's going on with it. So the first thing I would do is make myself a small xy table. And I would choose -2, -1, 0, 1, and 2. And here I'm doing 3 to the -2. Okay. So we know that that is going to be 1 over 9 because we have to flip it. So this is 1 over 9. Then I have 3 to the -1st is going to give me 1 over 3. 3 to the 0 gives me a 1. 3 to the 1st is 3, and 3 squared is 9. So I'm going to go into my graph, and I'm going to graph my base function so I can see where I'm starting from. So here again, I would graph my whole numbers first. So at 0, I'm up 1. At 1, I'm up 3. 1, 2, 3. And at 2, I'm up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. At -1, I'm at a third. So we're down here. And at -2, I'm at a ninth. Okay. So what you can see from this is that we are traveling along the axis here. And then when we get to our coordinate points, we're going to start shooting up very quickly. and thus this would be our base graph. Okay, and so here this would be your f of x equals 3 to the x. Now we need to do the other. So here we need to look at x and then y equals negative 3 to the negative x plus 4. Again, I would do the same, negative 2, negative 1, 0, 1, and 2. And you can do this into your calculator, just like we did the other problem, where you can either use it in this form or you can input it in the other. So remember, it was 4 minus 3 to the negative x. Either way you input it is going to work just fine. And so here you have to input your value in. So we would have negative 3 minus a negative 2 plus 4. So we would have to look at what that gives you. So in your calculator, you would do negative 3, raise your power, and negative, open a parenthesis of the negative 2, and then we have plus 4 equals, and this gives us negative 5. We would do the same thing for negative 1, 0, 1, and 2. Okay, so here I've got negative 3. I'm going to open my power and do negative of my negative 1 plus 4, which gives me 1 as a result. Now I'm going to raise it to the 0 of negative 0 plus 4 gives me 3. And then I have to do negative 3 raised to the negative of my 1 plus 4. And this is going to be 11 over 3, and I'm going to change that, which is 3.67. And then I'm going to do it one last time, negative 3, raise it to the negative of 2 plus 4. So here I get 35 over 9. Again, I'm going to change it, which is going to be 3.89. So you should notice here that we are getting infinitely close to 4. So I'm going to graph these points. So first and foremost, at negative 2, I'm down at negative 5. So 1, 2, 1, 2, 3, 4, 5. At negative 1, I'm at 1. So at negative 1, I'm at 1, which is right here. At 0, I'm at 3. So 0, 1, 2, 3. At 1, I'm at 3.67. So over at 1, 1, 2, 3, and almost to 4. And then at 2, I'm at 3.89. So again, 1, 2, 1, 2, 3, almost to 4. And we have a new graph here. And so this graph is infinitely close to my 4 right here. So it's traveling kind of almost at 4. And then I'm going to hit my points. And I'm going to curve down. And then I'm going to start curving down very quickly in this direction. Okay. And so this one is where my f of x was 4 minus 3 to the negative x. So you can see, if we compare it to the original, my original said that we were supposed to reflect over my y-axis, then reflect over the x-axis, and shift it up. Okay, and so if you look, we actually did just that. So that is a snapshot into being able to graph when we have more than just your exponential function. Okay. Now the big thing that we see most often is the idea of solving exponential equations. So again, an exponential equation is an equation where your exponent is a variable. We have two special properties that have to be kept in mind. One says if my bases are the same, then the powers can be set equal. Okay? So that property is going to help you solve most of your exponential problems. So we have this problem right here. The first thing we need to do is you have to rewrite your equation so that you have the same bases. The reason you want to do that is so that you can apply your property and thus solve for your variable. So here I want to ask myself, can I rewrite 16 into an exponent using a base of 4? Okay. Well, the answer is yes, because we know 4 squared is 16. So I have 4 to the negative x is equal to 4 squared. And then because of that, I can now use your property, which says that because my bases are the same, it means my exponents are the same. So using the property says that I can now solve negative x equals 2. I have to divide everything by the negative, so here we get that x is equal to negative 2. And this is the result that we were looking for. Okay. So now let's do it with something that's slightly more complicated. So what you have to ask yourself here is you need to ask yourself, can you rewrite both bases into the same base? Well, that means you have to look at what's in common. Okay, so the idea that we're using here is we want to reduce our bases to something smaller. So what's in common between 9 and 27? Well, the answer there would be 3. So in this case, I can rewrite 9 into 3 squared. So I have my new base is still being raised to the 2x minus 5, which means on the other side, I'm going to have its new base is still being raised to the x minus 2. Well, the new base here is 3 squared. And when I look at 27, that can reduce to 3 cubed. Well, this means we now have to apply product power rule. So I have to apply my powers together, which means this becomes 3 to the 2 times 2x minus 5 equals 3 to the 3 times x minus 2. Since my bases are the same, it means my powers are the same. Therefore, this becomes 2 times 2x minus 5 equals 3 times x minus 2. And from here, I can reduce. So distribute, this becomes 4x minus 10 equals 3x minus 6. Combine your like terms, and you get that x equals 4. This is what we were looking for. Okay. So let's do a couple more. So I have 7 raised to the x squared plus 3x is equal to 1 over 49. Again, I want to ask myself if I can rewrite 49 into the base of 7. Okay, that's my goal. So, what do I know? Well, I have 7 to the x squared plus 3x is equal to 1 over 7 squared. Well, I still need to make it a base, which means at this point I need to flip it and make the power negative. In other words, you don't want it to stay in its fraction form. You need to have a base that has 7. So this becomes 7 to the x squared plus 3x is equal to 7 to the negative 2. Now my bases are the same, which means I can apply my rule, which says that I need to solve x squared plus 3x equals negative 2. So we're going to solve that quadratic, move the 2 over, x squared plus 3x plus 2 equals 0. I can factor this into its parts. So this becomes x and x. I need factors of 2 that'll give me a positive 3. Since both my signs are positive, I have positive, positive. And the only factors of 2 that I have are 1 and 2. I now need to solve. So I need to set both parts equal to 0 and solve. So x equals negative 1 and x equals negative 2. And in this case, I have 2 answers that will satisfy the problem. Let's look at this one. I have 4 to the 2x minus 5 and 8 to the x over 2. So I want to rewrite both bases using a base of 2. Why? Because 4 and 2, or 4 and 2 and 8 all have something in common, which is 2. And so here I'm going to have a new base raised to the 2x minus 5 is going to equal a new base raised to the x over 2. And what is that new base? Well, this one's going to be 2 squared, and 8 is the same as 2 cubed. Because my bases are the same, I can now apply my power rule, which says this is 2 to the 2 times 2x minus 5 equals 2 to the 3 times x over 2. Again, since my bases are identical, it means that I can set my powers equal to each other. So I can solve the following. 2 times 2x minus 5 equals 3 times x over 2. And I need to solve this. So distribute that 2 through. So this becomes 4x minus 10 is equal to 3x over 2. To get rid of my fraction, I want to multiply my entire equation by 2. So that means I'm going to multiply all 3 terms by this 2 right here. Okay, so multiply the first, the second, and all the way over to the other side, thus removing my fraction. So 2 times 4 gives me an 8x. 2 times 10 is minus 20 is equal to a 3x. Combine your terms and solve. You get that x is 4. And this was what we wanted. Now for this next one, notice I have a lot of e's. Okay? However, it's really not that bad. What we have to do is you just have to use your power rules and try to apply your property in order to simplify things down as far as you can. The first thing that you need to remember is that everything we have is always over 1. So when we're talking about this side over here, the first thing we need to do is multiply straight across the top and straight across the bottom. So this gives me e to the x plus 2 raised to the third is equal to e to the x over e to the 3x. Notice we have the quotient rule. So the quotient rule here, remember, means to subtract your powers. Top minus bottom. Okay. So this is going to be 1 minus 3 gives me e to the negative 2x. Now on this other side, we have power to a power, which means you need to multiply those powers together. So this is going to be e to the 3x plus 6. Notice my bases are the same. It doesn't matter that they're e's, the point is that they are now the same. So we now get to solve the problem that 3x plus 6 equals negative 2x. Combine your terms and we get that x is negative 6 over 5. And this is all that we were looking for. Okay. Last but not least, what happens if my bases are fractions? Well, if they're fractions, again, you're going to do the same thing. We want to rewrite your base into the same base. So in other words, you need to ask, can 8 over 27 reduce to 2 over 3? Okay, yes or no? Well, in this case, it can. And so here what happens is we have 2/3 to the 5x plus 7 is equal to, and then we reduce it. And here we have 2/3 raised to the 3 to the 4. And so here I now have to use power to a power. So I've got 2/3 to the 5x plus 7 is equal to my 2/3 to the 12. My bases are the same, so it means now I just simply have to solve. So I am going to solve 5x plus 7 equals 12. So when I combine my terms, I get that x is equal to 1. And this was what I needed. So again, if you have any questions, please let me know. Otherwise, I'll see you next time.